Okay, what's up, guys? Today we're going through the Level 2 2022 calculus paper, just to help anyone that needs it, and just for a little bit of fun. So I haven't looked at this paper. I didn't do this one. I would have done the one Level 3 this year, but anyway, let's go through it. So so we're finding the gradient of this function at x equals 3. So in order to do that, we need to take the derivative, because that will give us the function of its gradient, or the gradient function. So f of x is going to equal, so in order to differentiate, we need to times the exponent by the number in front here, and then we need to subtract 1 from the power. So we're going to go 8x to the power of 3, this is so hard to draw with, plus 12x squared minus 40x, and then that's it, because we know our 5 is just going to become 0. Okay, following this, we need to find where the gradient of the function, what the gradient of the function is when x equals 3. So if we substitute 3 into here, we should get our answer. So 8x to the third, to 8 times 3 to the third power, 3 to the third power, oh my goodness, plus 12, 3 to the second power, minus 40 times 3. Okay, so this first one is going to equal 8 times 27. 8 times 27, you can obviously put this into your calculator. I like to do it in my head because it's fun. Plus 12 times 9. And then minus 120. Okay, so we know this is equal to, so it's 160 plus 56, so it'd be 216. Oh, what happened there? 216, I believe. Just double check that. 160, yep, that's right. Plus, so 90 is 108. And we got minus 120. Okay, then what do we have now? So these two, we're going to get 324, I believe. And minus 120 is going to be, so that's 324, so it's going to be 204, I believe. I might just check on my calculator real quick, because I always make mistakes when doing this. I don't know why. Simple mistakes always get you. So 8 times 3 to the third power plus 12 plus 12 times 9 minus 120. Yeah, so 204. Yeah, okay, so that should be the gradient function at that point. We can also use, we could use Desmos to show that, but obviously you can't do it in an exam, but it might be intuitive. Anyway, you can try that if you want on Desmos. Anyway, next part. For the function f, the graph of f of x passes through the point 3, 4. Find the equation of f. Okay, so we know this is our gradient function, okay? And we know that the graph of f of x, so this integrated, is going to go through the point 3, 4. So in order to integrate, well, you should know how to integrate, but we're just going to essentially add 1 to the x power and then divide by the power. So I'll show you. So if we're going to do f of x, we're essentially going to get 4x minus 6x squared over 2, because I'm just dividing by that power, and then plus 2x to the power of 3 divided by 3. Okay, so following that, we're going to go and plus c. Okay, following that, now we need to substitute in our y or f of x value and our x value, and then we should be able to figure out what c is. So our f of x is 4. This is going to be 4 times 3. This is going to be minus 3. We know it's going to be 9. So that's what 3 squared is. Plus, so 2 over 3. And it's going to be 2 times 27. Because that's 3 to the power of 3. Over 3. Okie dokie. We're going to have, I forgot the plus c again. Plus c. Okay, we're going to have 12 minus 27 plus 54 over 3, which should be 18, I believe. Plus c, oh my god, plus c. Okay, so this is going to be 18, 54 divided by 3. And then, so 18 plus 12 is 30, minus 27 is 3. And if we so this is going to be 3 plus c. That equals 4 on that side. So that means c is going to equal 4 minus 3, which is 1. So, find the equation of the function. So I guess we have to write out the equation. I'm not going to write out the equation, but I'm just going to say it would be this same equation, but putting 1 as c there. Okay, so you just have to write that out again, I'd say. I'm sure you could do that. Is that the equation? Find the equation. Yeah, that's it. Okay, next question. Use calculus to find the values of x for which the graph of function f of x is decreasing. Okay, so when it's decreasing, we know that the gradient function is going to be, well, negative, because it's got a negative gradient. So we need to find f dash x. Ooh, that is great. F dash x. We got to find that. So we have to differentiate. So as I said earlier, we multiply by the exponent and then take one from the exponent, take one away. So 2x to the third power divided by 3. Well, we're just going to times by 3 times 2x. And we're going to take one from the power, so it's going to become 2. Oh my goodness. That's all divided by 3. As you see, those are going to cancel. We'll come back to that. 2 times 3x divided by 2 minus 20. Okay, the 2's cancel as well there. Okay, and then we have 2x squared plus 3x minus 20. Okay, now we have to, so this is our gradient function. Now, so the next thing we need to do is make that, it's going to need to be less, if it's decreasing, than f of x. So this needs to be, actually we'll put 0 here, 0, so it needs to be less than. So this function here needs to be less than 0 because it's decreasing. So we have 2x squared plus 3x minus 20. Okay. Now we need to factorize. So we're going to have negative 40, and then we need to find two numbers that times the negative 40 and add to 3. So 5 and 8. So it'd be negative 5 and positive 8. So 2x squared. Oh my goodness. Plus 8x minus 3. What am I doing? Minus 5x minus 20. Okay. So now we're going to factorize. So we have 2x out of the first pound. So we're cutting this in half down the middle here. 2x, x plus 4, and then minus 5x plus 4. And because we see that both these brackets are the same, means it's highly likely we've done this correctly. So it's going to be 2x minus 5 and x plus 4. Hope you guys understand what I did there. Should be pretty simple. It does take a while to get used to, but okay, so we can quickly check this. 2x squared minus plus 8x minus 5x and then minus 20, so that's going to be correct. Okay, so now we need to find where this is less than 0. So let's draw something out here. This is an axis of our parabola. So we don't actually, doesn't matter where it is. So let's say we have this is an axis. This is our x. This is our y. And this is our parabola like this. I'm just going to say it goes like that. I probably should. Oh, that's all right, actually. Okay, so we know that it crosses at negative 4, x equals negative 4. So this is where it's going to equal 0. And 5 over 2, so 2.5. So I'll just go 5 over 2. That is so annoying. 5 over 2. Okay, so that's that point there. Now, we have to find where it is less than 0. So it's less than 0 all through here. Okay, so therefore our answer for x is going to be negative 4 is less than x, and that's less than, I'm going to say 2.5. Same thing as 5 over 2. Okay, is that all it's asking? So using it to find the values for x for which the graph is decreasing. So that's right. So it would be there. Okay, the tangent of the curve point has a gradient of negative 6. Okay, so this is our curve, and at the point 2, negative 10, there's a gradient of negative 6. So again, we need to find our gradient function. So we can get at this right now. So, and we'll find the values of constant p and q. So we need to find out, always, if it's to do with gradient, find the gradient function. Okay, if we are going to differentiate this, we're going to see that the exponent is just going to be 1. So if we times p by 1, we get p. And if we take 1 away from the power, we're going to get 0. So x to the power of 0 is just 1, so it's just going to be p. And then the next one is just going to be minus 2qx, 2qx. Don't forget the x. Now, at the point 2, negative 10, so when x equals 2, we know the gradient equals negative 6. So p minus And so if x equals 2, so we'd sub x into here, and we're going to get 2 times 2q, so it's going to become 4q. So I just put 2 into x there. Okay. Now, after doing that, we know that at the point doing the gradient of -6. So we know that the f of x equation has the coordinates 2, -10 in it. So we should be able to use that to create another equation. Yes, this is how we do it. So -10 equals 2p. So I'm just substituting these coordinates into that equation there. 2p minus, and it's going to be 4q. Okay, so now, I forgot the equal sign. -10 equals 2p minus 4q. So I substitute 2 into both of those, both x values. I got that, and I also did the same thing down here. Okay, so if we now use simultaneous equations, we should be able to solve this. So we'll go for 4q. Get rid of the 4q. So 4q is going to equal, what's it going to be? It's going to equal p plus 6. So I just rearrange this equation up here. So I just added 4q to this side and added 6 to this side. Then if we go -10 equals 2p minus p plus 6, because that's what 4q is equal to, then we're going to get p minus 6 equal -10. That means p equals -4, adding 6 to both sides. And then if p equals -4, we know that 4q equals -4, which is p, plus 6. So I'm just using this equation over here now. That equation there. So just from those two. Okay, and that's going to equal 2, 4q. That means q equals 1/2. So that's our p and q value. And you can substitute it back in if you want. We can try it. Do you want to do it? It should work. Should work. If it's not, then I'm in a mistake, but it should be sweet. Yeah. Okay. Here we go. Here's a good one. So, a new business is designing a logo based on a stylist H shape, as seen in diagrams. The logo is to be designed with 2 semicircles and 2 straight lines. The owner of the new business wants to include space for the company's name inside the shape, so is asked the design to maximize the area inside the shape. The owner plans to build a replica of the logo, and due to material constraints, the total perimeter of the shape must not be greater than 80 centimeters. Here's some examples here. So when you find the maximum area, and these guys methods to show that this is the maximum. Okay, so we need to have the perimeter equal to 80. So let's first do an equation for that. So just checking two semicircles. So those are designed with 2 semicircles, 2 straight lines. Okay, sweet. So we need to find the perimeter. So the perimeter, well, we know this semicircle here. Damn it, that wasn't very good. But anyway, we know that the circumference of a circle, oh my gosh, equals 2 pi r. Okay. Therefore, half the circumference, which we have got here, would be half of that. But we don't actually need to half it because we've got another semicircle of the same radius over here. So, yeah, we can add our total perimeter. We put P equals, so it's going to be 2 pi r is going to be the first part. And then we need to figure out an equation for the straight line. How are we going to do this, I'm wondering. Well, how does the... Okay, so the area is always high. Well, if we know... Maybe if we just go plus 2L, and we call that L, because there's no actual... So we're going to play plus 2L. And so that's going to equal... So it's going to equal 80. That equals 80. 80. We want to maximize the area. So the area is equal to... Oh my gosh. Is equal to 2R times... What's going to be 2R times... What is it? L. 2R times L. So that's the rectangle. That's the rectangle. 2R is the base, L is the height. And then we need to minus pi r squared. Alright, this is how we do it. Okay, sweet as. So, given that, we know that 2L equals 80 minus 2 pi r. That means L equals 40 minus pi r. Okay. And then we can simply substitute that into our area. Area equals, oh my goodness, equals 2R times 40 minus pi r minus pi r squared. So what we've done there, we knew the perimeter, we knew the equation for the perimeter, and we knew the equation for the area. And then we just used those two equations, basically like a simultaneous equation, to create one variable. From here, we need to just quickly expand out. So we're going to have 80R minus 2 pi. Yo.
Eli wants to know if you can teach us that tomorrow.
Yeah, I can do that.
Alright.
Just give me a time.
You said after my exams.
Bet. Okay, so I've done that. Oh, what have I done? 80R minus 2 pi r squared. There we go. So now we have to move on and continue simplifying this because we know we've got a like term there. Okay, sweet as. So just checking we've done that right. So we've got 80R minus 2 pi r squared, and that's a minus there. Minus pi r squared. Yep, so that should be our equation for area. Now, in order to find the maximum area, we need to find where dA dr equals 0. Okay, so first thing here, we know that equals 80. So I'm differentiating right now. 6 pi r, and then we need to find where that equals 0. So the r value when that equals 0. So if we do this, we know that 80 equals 6 pi r. That means that r equals 80 divided by 6 pi, which would be approximately 4, which seems reasonable. 4 for r, and then L, yeah, that seems about right. So we're going to, so r equals 80 over 6 pi. Now we need to substitute that back into our equation to find the area. Well, we know the area equals 80r minus 3 pi r squared. Area equals 80r minus 3 pi r squared. So we are going to substitute that in. 80 over 6 pi r times r times 80r. Sorry, look that up. Just redo that. Equals 80 times 80 over 6 pi minus 3 pi, and then we have 80 over 6 pi squared. 80 over 6 pi squared. So if we try this in our calculator, 80 times 80 divided by 6 pi, and then minus 3 pi times 80 divided by 6 pi, that's all squared. We're going to get 169.7 equals 169.8. And what's the units? Centimeters. So centimeters squared. So I believe that should be the answer.